Now we will study how the depth first search algorithm works. In depth first search algorithms take graph as the input. Okay, graph means here we are providing vertex as well as edge to the DFS. And the output is graph G with its vertices marked with consecutive integers in the order they are first encountered by the DFS traversal. That means this output will return the order in which the vertices are actually visited. Marked with the some integer value. Okay, the node which is visited first is marked with 1. The node which is visited at the next is visited 2. Like for each vertex is marked with some integer numbers. That order will be, it will return. For that one, we have to mark each and every vertex in the graph V. We have to mark each vertex in V with 0 as the mark of being unvisited. In graph, all the vertices are marked with 0. And we have to start one counter here to mark the vertex. Initially, the counter is starting with 0 here. Okay. Now, I have to pick for each vertex V in V do. If V is marked with 0, DFS. I have to pick any one vertex. I have to pick any one vertex in the set of vertices and start the DFS process from there. If that vertex is not visited, start the DFS process from there. Now, how the DFS actually works? This DFS works recursively. All the unvisited vertices connected to vertex V by a path and number them in the order they are encountered by a global variable count. Okay, now here first I will pick any one of the vertex V from the set of vertex here. Okay, and we check whether that V is actually visited or not. If that vertex is not visited here, I am applying the DFS algorithm here. In the DFS, first we have to assign the counting value for that V. So first I will increment the count value from 0 to 1 here. Then assign that count to the V. That indicates V is visited, first visited. Okay, then I will identify all the adjacent nodes of V. Okay, I will pick any one adjacent node and that is indicated by W. First I will pick all the adjacent nodes. Okay, then I will pick one adjacent node called as W, which is adjacent to V. Then we have to check if that W is visited or not. If that node W is not visited, I have to apply again the DFS algorithm on W. When you apply the DFS algorithm in W, the W becomes V here. This value, the adjacent node value, is actually passed to V here. Means it is the, we have to apply the algorithm again one more time. The count value 2 is given to the next adjacent value. Again, it goes in depth. It goes in depth until there is no any unvisited edges. Okay, whenever it founds the dead end, this if condition becomes false and come back to the recursive process. Okay, the recursive process stops here, go to the previous node. In previous node, find the another adjacent node W and do the process again and again. This is called as depth first search algorithm. Once this DFS algorithm stops, we have to go back and see, is there any vertex which is not visited in the graph. In some situations where the graph is not connected or graphs are digraph, in that cases some nodes are not visited. Whenever you start from a particular node, some nodes are not visited. In that case, you have to pick another node which is not all started and start applying the DFS algorithm on them. And try to visit all the other nodes from that points. Like that, we have to continue the process until all the vertex in the graphs are visited. This DFS is actually used for visiting all the unvisited vertices. Okay. This depth first search algorithm is efficient algorithm, and its time efficiency is actually depending on the data structure used for representing the graph. You already know graph can be represented using adjacency matrix as well as adjacency list. But depending on which data structure you are using, its efficiency will be calculated. If we are using an adjacency matrix for a graph, the depth first search algorithm's efficiency is calculated as theta v square. That means the total number of vertices in the graph, its square. Means if you have a n number of items in the graph, we have n number of rows and n number of columns. All items of that matrix will be visited. V square means number of rows into number of columns. Okay. And adjacency list represent here. If you use the adjacency list for the graph, its efficiency is calculated as number of vertex plus number of edges here. This V indicates number of vertex, and this E indicates here number of edges. When you total it, you got the efficiency. So it is more efficient algorithm.